Welcome to our CFP exam prep discussion. Today we're diving deep into a crucial investment concept that often appears on the exam, the coefficient of variation, or CV. This powerful tool helps us compare investments with different returns and risk profiles. Let's break down the coefficient of variation. It's calculated by dividing the standard deviation by the expected return, giving us a risk per unit of return measure. Think of it as a way to level the playing field when comparing investments with vastly different returns. The lower the CV, the better the risk-adjusted return. Here's a practical example that often comes up in the exam. Imagine you're comparing two investments. Investment A has an expected return of 12% with a standard deviation of 18%. Investment B has an expected return of 8% with a standard deviation of 10%. At first glance, investment A might seem more attractive due to its higher return. However, when we calculate the CV, we get a different story. Investment A's CV is 1.5, while investment B's CV is 1.25. This reveals that investment B actually offers better risk-adjusted returns. Many test takers make the mistake of focusing solely on standard deviation or expected returns in isolation. The exam loves to trick students by presenting scenarios where the higher return investment isn't necessarily the better choice when risk is considered. Remember, the CV helps us make more informed comparisons by combining both risk and return metrics. Another common pitfall is misinterpreting the CV results. Some students mistakenly think a higher CV is better because they associate it with higher returns. Always remember that with CV, lower is better. It's like golf scores, not basketball scores. The exam might also present you with questions involving negative returns. Here's where many students stumble. The CV becomes meaningless when dealing with negative expected returns because it can give misleading results. The exam might include this as a trick question, so be on guard for scenarios involving negative returns. Let's walk through another example that demonstrates why CV is so valuable. Consider comparing a technology stock with a utility stock. The tech stock shows an expected return of 20% with a standard deviation of 30%. The utility stock shows an expected return of 6% with a standard deviation of 7%. The tech stock CV would be 1.5, while the utility stock CV would be 1.17. Despite the tech stock's much higher return, the utility stock actually provides better risk-adjusted performance. When preparing for the exam, make sure you can quickly calculate CVs in your head for simple numbers. Practice with different scenarios until it becomes second nature. The exam might not directly ask you to calculate CV, but understanding this concept could be crucial for answering questions about portfolio comparison and risk assessment. Remember that CV is particularly useful when comparing investments across different asset classes or with significantly different returns. However, it's just one tool in your analytical toolkit. The exam might expect you to know when CV is most appropriate and when other measures might be more suitable. In essence, the coefficient of variation helps us make smarter investment comparisons by standardizing risk relative to return. Keep practicing with different scenarios, and always be mindful of the common traps involving negative returns and misinterpretation of higher versus lower CV values. This concept is fundamental to modern portfolio analysis and will serve you well both on the exam and in your future practice as a financial planner.